Thank you for joining me for this video. I am Mr. Ish. I hope all of you are doing well. In this video, I'm showing you two exemplary integrals. Two specific integrals that you should be aware of, especially in 12th grade math class when you are looking at calculus for the first time, because these two specific integrals will demonstrate two very important integral properties. I have here at the top left corner the antiderivative procedure for a polynomial, x to the n plus 1 divided by n plus 1. Our first integral we are looking at is this. If I have minus 1 to 1 x dx, nothing here is out of the world, but it's very important to understand it. This here is my function. What does it look like? It looks like this. But when I'm putting it from minus 1 to 1, I'm looking at it from minus 1 to 1. Demonstrate where the region is with regards to above or below the curve. That's what we're looking at. Remember, nothing here is drawn to scale, but if you're looking at it accurately, you have an equal negative area and equal positive area. That's what we have, and we're looking at the cumulative net area. When you do the antiderivative here, you have x to the power of 1. Look at it through this. X to the 1 plus 1 divided by 1 plus 1. This is the antiderivative. When you do the antiderivative of your function or your integrand, the integral sign goes away. You're looking at it from 1 and minus 1. X squared over 2. 1 and minus 1. Put the upper limit in, you'll have a 1 over 2 minus, it's always the difference of the two limits. Put the lower limit in, minus 1 squared is a 1 over 2. What do you get? A 0. Exactly what you expect. Equal negative area, equal positive area, cancelling out to give you a 0. Why did I tell you about this? Because of this. It's an odd function. For the odd function, which is symmetric around the origin, you have symmetric limits. Minus 1, 1. This is the property you should be aware of. Minus a to a for an odd function. The integral end result will always be a 0. This integral here demonstrates that in terms of an example. The odd function minus a to a. Symmetric limits. Minus 1 to 1. Minus 10 to 10. Those type of limits. The end result is a 0. Now let me show you your second integral that you should know. Minus 1 to 1 x squared dx, again an exemplification or an example of the property we will be looking at. Graph x squared looks something like this, but we're looking at it from minus 1 to 1. You have something which looks like this. In terms of areas, you have equal positive, you have equal positive. You are essentially looking at 2 times that one positive area. 2a, twice the area. Do the antiderivative, x cubed over 3. We're looking at it from 1 and minus 1. Put the upper limit, you'll have a 1 over 3 minus, put the lower limit, minus 1 over 3. You have a doubling going on, 2 over 3. What's the property we're looking at? This, minus a to a. For an even function, you can always look at it as from 0 to a, f of x dx, but you double it. If I'm looking from minus 1 to 1, I could have just looked from 0 to 1 and found one area and multiplied by 2. An even function symmetric about the y-axis having symmetric limits, you look at it through this way. I could have done this entire integral as 0 and 1 x squared dx and then put a 2 before it. It would be still equal to 2 or 3. So keep these two properties and two examples in mind. Thank you. Have a good day.